Hi guys, sorry that I'm not there today. I wish I could be, but I'm not. And so I'm going to do a couple of different videos for you guys and so that you can stay on track and still learn the things that we need to learn today. So the first thing is bell work. You guys should have been working on bell work for the past little while and hopefully have answers for all of these because they all should have been really doable and a good review actually of the assessment that you took. So number one, it says convert the function from standard form into vertex form, then identify the vertex. So that's what we're working on right now. Right here, it says function form, or sorry, from standard form to vertex form. So this is completing the square, if you remember talking about that. I solved it a touch differently than we did in class, but hopefully you'll be able to follow along. So in class, we would have moved that 67 to the other side. I didn't end up doing that, but that's okay. I solved it differently than you did. Don't worry about it. Took out the GCF of a -2. Knew that I needed to put in that 36 and did that work. Answer should have been y equals -2 times the quantity x plus 6 squared plus 5. Now remember, where are we getting that 6 from? We can do that 6 squared over there. If not, you can do all of the factoring work. That was up to you. Number 2, it says find the zeros of the function. Remember, zeros are the same as roots and solutions and x-intercepts, and I don't know, there's probably something else I'm forgetting. So make sure that you find the zeros of the function. You're going to factor and set those pieces equal to 0. So if you factor it, you have x minus 2 and 3x plus 5. Set each of those equal to 0. So x minus 2 equals 0 and 3x plus 5 equals 0. Solve each of those and get x equals 2 and x equals a -5/3. If you don't like the fraction, you can make it a decimal, a -1.6 repeating, or a -1 2/3 would be the same. Okay. Third question on bell work. Third question says, if the following function were to be graphed, where would it cross the x-axis? We just said that. A solution, a zero, an x-intercept, they're all the same. So where would it cross the x-axis? On your x-intercepts. What are your x-intercepts the same as? Your x-intercepts are the same as your solutions. So take out your GCF of an x. You're left with 7x squared plus 22x plus 3. Then factor that statement right there, x plus 3, 7x plus 1, and set each one equal to 0. I really, really hope you set that x equal to 0 because that's part of your answer. We've had that conversation before. If your GCF is a variable, it affects your answer. Well, if your GCF is x, that's a variable. And so it's part of your answer. You get 3 answers right there. Okay? All right, I think that's all for bell work. I'll be back to talk about your homework when we go over that in just a minute.